record. Okay. First of all, I'm trying to do this review like this. Last time I did last time I start from the theoretical stuff and then move to the review, but today I'm planning to do start from the review. So start from the review question, then I'm going to theory parts and explain both review questions as well as those related theory parts. Okay, so I need to share my screen, so please give me a minute. Okay, I'm trying to share my screen, so share the screen. Okay. Okay, I think you can see this. Okay. Okay, I'll start from the question number 1. This is the review which I send you with the answers. Okay, you can find the handwritten answers for this review in on the blackboard as well. So I think I have given answers as well. Okay, let's try to start from these questions, and if it is necessary, let's move to the theoretical parts as well. Okay, find the probabilities. Oh, first of all, I should say that this exam, a mid exam 2, based on chapter 5, 6 and 7. Okay, so first in this review, first 7 8 questions based on chapter 5. Okay, so this first question, find the probabilities. So you can see, find the probabilities, P probability of E or F. Okay, so you know that these E and F are events. Okay, they are mutually exclusive. Okay, let's go to the theory part. So where is it? Chapter 5. Okay, here you go. This is chapter 5. Okay, chapter 5. Is chapter 5 based on probability and random variables. So what is the probability? Probability of an event mean the frequency of that event occurs. Okay, the frequency of that event occurs divided by total number of possible outcomes. That's the easiest way to define the probability. Okay, so there are few things, actually we call them properties. First property is the probability of an event is always between 0 and 1. So you should remember that if it is a probability value, then it is definitely in between 0 and 1. It can be 0 or 1 as well. Okay, so if probability value is 0, which means that event cannot be occurred. Okay, same case, if probability value is 1, which means that event definitely happens. Okay, so there is an example. I cannot write here. Okay, let me open it again. I don't know why I cannot write here in this PDF. Let me check. So how should I write it? Okay, let me check. Chapter 5. Okay, great. Okay, now we have example. First, before we okay, why this happened? Okay, sorry for that. uh, Before we talk about the question number 1, let's do this example. So using this example, I can explain first few questions in your review. So following table shows numbers of cardiovascular disease by age group during 1 year. Okay, just focus on this table. Age group is a left column, and the frequencies they have given with respect to each age group. Okay, so these are the frequencies for age group 0 to 19. It has 810. That's the frequency. Okay, so what about the total frequency? This is the total frequency. This is the total frequency. Okay, whenever you need to find a particular probability that belongs to a particular age group, let's say I need to find the probability. I'll write somewhere here, probability of age group 0 to 19. Okay, actually this is not the correct way to write this, but to understand, I just need to find the probability which belongs to age group 0 to 19. So what is the method? What is the formula? We find the probability. Frequency belongs to that event divided by total number of outcomes. Okay, so what is the frequency belongs to this group? It is 810 divided by total frequency, which means here is 20, 88, 67. Okay, it's about 200,000. Okay, so 810 divided by this total frequency gives you a probability value. If you divide this, you will see that this value less than 1 and greater than 0. Okay, this is the way how we find the probability of a given event. Okay, event can be anything. Event can be, so I can say my event is age group 0 and 19. My event is age group in between 40 and 49, something like that. Okay, event something we define. So suppose that you select a woman randomly, then find the probability that selected woman is in her age 51. Okay, so where is 51? Here, right? 51 belongs to here. So you can find this probability. How? The frequency belongs to that given group. What is the group? We need to find her age 51. Age 51 belongs to this group. So what is the probability of this group? 20,983 divided by total frequency 20, 88, 67. So this is the quotient. Okay, so this piece gives you the probability that selected woman is in her age 51. Okay. Okay. uh Let me calculate these values using calculator. This is my calculator. Okay, I have my calculator, so I'll show you exact value. So this gonna be 20,983 divided by 2867. So this gonna be 0.10046. Okay, if you write it like 3 or 4 decimals, that's totally fine. Okay, so this probability value is 0.10046, right? Okay, let's do another one. This is the last one I'm going to do in this example 3. Find the probability that selected woman aged between 50 and 79. 50 and 79. So in what is the groups that belongs to 50 and 79? See this part, 50 and 79. Okay, so you have to get the frequencies which belongs to these age groups, then divide by total frequency. So what are the frequencies you have to add? 50 to 59, there are 20,983, plus 60 to 69, it is 36,884, plus 70 to 79, which means 65,017. So this sum divide by total number of possible outcomes, which is 20, 88, 67. Okay, so once you use your calculator with these values, so no problem, you can use your calculators. Actually, you have to use your calculators, otherwise it is impossible to calculate these calculations by hand. Divide by 27. Okay. Oh, sorry. So please check your inputs when you are using your calculators, especially brackets and those stuff. Okay, sometime if you miss a bracket, then you get a wrong value. So please pay your attention when you are using your calculators. Okay, so this is something like if you use your calculator, first you have to calculate this, then divide by this value. Okay, so this value gonna be 0.5883. So the probability that selected woman aged between 50 to 79 is this much, 0.5883. Okay, okay, so let's go to our review back here. Always I have to share my screen, so sorry about that. Okay, okay, so still yes, we have to where was I? This one. Still I have to couple of things. Okay, events. Event which mean sorry, this is gonna be really hard. Okay, okay, Uh, First, we need to define what is event. So I'll tell you what is event. So before you know what is the event, there is a word called there is a term called sample space, which means collection of all possible outcomes for an experiment. So sample space bill it consists of all possible outcomes in our experiment. This we call sample space. Okay, so event mean collection of outcomes of the experiment, which means a subset of this sample space. This is we call an event. Okay, something like that. Within this sample space, there are many events. Okay, it based on how you define the event. So we denote them using capital letters. Events we denote by capital letters. Okay. 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 Tossing a coin. If you toss a coin, you know that coin has only two sides, head or tail. So sample space, which means all possible outcomes, okay, in our experiment. So head and tail, these are the outcomes in our experiment, head or tail. So event A, I denote that I mentioned that the side above is the head. When you flip the coin and check the side above is the head. Okay, so it is our event. Okay, if you need to find the probability of that particular event, so I can write it like P A. We call it we read this P of A, which means probability of event A. That's how we read this probability of event A. If you need to find this probability, yes, you can find it. What is A? A is this. Okay, this is how we denote or how we mention probability of an event. Okay. Okay. I think at least. Okay. These are very important terms. At least. At least mean there should be at least that number of occurrences in that event. Here, at least one head. So, at least one head should be there. No head mean there should be no head. Something like that. We can define our event like any way you want. Okay, but it should give you a precise idea what is this event is. Okay, okay. There are some relationships among events like my event, let's say I have event A and event B. Okay, I'm telling you that my event B is not event A, something like that. Not E. Not E mean everything does not belongs to that particular event. That's we call not that event. This event we call E. So not E mean the event E does not occurs. Okay, if you have your sample space like this, your event is this. This is your event E. So not E mean whatever within this red color box in this free space. This is your not E. Okay. Sorry. A and B. If you have two events, okay. Let's say this is my sample space. Okay, this is my sample space. This is the easiest way to denote the sample space. Okay, I'm going to draw two events like this. Okay, this is my event B, this is my event A. This is we call Venn diagrams. Okay, so this is my event A, this is my event B. So A and B mean event A should be there, event B should be there. Okay, both events should be there. Okay, which means in general we call it both A and B occur. Both A and B occur. So where's the place both A and B occur? In this intersection, right? So in contrast, if you have A and B like this, and this might be A or B, A or B, which means either A can happen or B can happen. That's what it means. So A can happen, B can happen. So everything belongs to A and B. A and B mean not this and, A and B. Okay, which belongs to this both events. Okay, okay. This is how we uh, yeah, exactly what I mentioned last time. This is the not E. This is A and B intersection. This is A or B, both events. Okay. Uh, okay. Can we find the probabilities? No, we don't need this one. Okay, mutually exclusive events. Mutually exclusive events mean two or more events if they don't have any common area or common outcomes. If they don't have common outcomes, we call them, they are mutually exclusive, which means your A, this is my sample space. Okay, everything we are talking about events should live inside a sample space. Okay, so everything inside your sample space. This is my A, this is my B. Oh, another event, this is my C. I have three events that you can see that there are no common space or no common outcomes between these uh, events, among these events. Okay, between these A and B, or A and C, or B and C. Okay, no common outcomes, so we call them mutually exclusive. They are separate events. Okay, see, mutually exclusive event A and B, if they have a common space or shared space, or we call the common outcomes, they are not mutually exclusive anymore. Okay, okay. There is okay, we don't need to describe these things. Okay, this is what we need to do our first few questions. Probability notations. So I showed you before how we denote a probability of an event. If I have an event E, we denote probability of that event E like this: probability of E, probability within brackets, the name of that event. So we read that probability of E. Okay, okay. uh, I'll do this example and go to the questions. Okay, consider an experiment of rolling balanced die. Use probability notations to express the probability that the die counts up an even number. Okay, first of all, sample space. Sample space. Whenever you need to write the sample space, use these curly brackets. Okay, write your sample space within this curly bracket. That's the general notation how we used to write the sample space. So within this curly brackets, you have to write all possible outcomes within our experiment. So what are the samples? What are the all possible outcomes? Rolling a balanced die: 1, 2, 3, 4, 5, and 6. Right? These are the only 6 possible outcomes we can see when we are rolling a die. Okay. How many even numbers here? 1, 3, 6. There are 3 even numbers. What are the total outcomes? 6. So this is going to be 1/2, right? So probability that the die comes up an even number. So how many even numbers? 3. What are the total number of possible outcomes? 6. So 3 divided by 6, it is the probability of die comes up an even numbers. Okay. Okay. So A denote the event that the die comes up an even number. Okay. So this A means the event. So you have to write, if you use this notations for that event, you have to write what is this notation is. Okay. The event that the die comes up an even number. Okay. Then you can calculate probability of that event. PA. What is PA? Probability of this event. A means event that dice come up an even number. So what is the frequency belongs to that event? It is 3 divided by total number of outcomes, 6, 1/2. Same thing, but using notation. Okay. Okay. As I tried to explain you earlier, at least these are really important. Okay. At least mean everything greater than that given number, including that number. Okay, greater than or equal to that number. At most, everything up to that number, less than or equal, including that number. More than, which means it is strictly greater than to that given number. Less than, strictly less than to that given number. Between actually when we use between, there are two subgroups of that between 1 and 5. Inclusive mean you have to consider 1 and 5 as well. Okay, which mean inclusive between 1 and 5. Inclusive mean 1, all values in between 1 and 5, including 1 and 5. Okay, so it's like this, 1 and 5 is there, but we say between 1 and 5 exclusive, which mean all values strictly in between 1 and 5, which mean except 1 and 5. Okay, so this is really important. So this one goes to special addition rule. There is a rule we call addition rule. So when we are dealing with these kind of probabilities, these kind of events, we need this addition rule. It is really important, this addition rule. It is really easy. If we have two events and they are, see this word, mutually exclusive, which means A and B are like this. This is my A, this is my B, something like this. They don't have a common space, which means they don't have a common events. Okay, they are mutually exclusive. Then you can write P A O B is PA plus PB. I'm sorry that I'm reading this PAPB. Actually, you should read this like probability of event A, probability of event B, but I used to write it PAPB. Okay, so probability of A or B, which means you can simply write it probability of A plus probability of B. What is this A and B? They are mutually exclusive two events. Okay, you can extend this up to any number of events. Like if you have A, B, C up to whatever. Okay, it doesn't matter how many, but this should satisfy. Okay, mutual exclusive, all events should be mutually exclusive. Then you can write probability of A or B or C or whatever equals probability of A plus probability of B plus probability of C, something like that. Okay, okay, let's do this example and I can explain you, or I think first few questions. Okay, so the relative frequency distribution size of farms in US. Okay, they have mentioned sizes, their relative frequencies, and the event. Okay, so they consider size under 10 as event A. And for an example, somewhere here, they consider sizes between 500 and 999 inclusive as event G. Okay, so let's try to find one question. What is the probability that randomly selected farm has between 100 and 179 acres inclusive? So 100 and 179, 100 and 179. Okay, here, this is what we are talking about. Acres in between 100 and 179 inclusive, which means including 100 and 179. So what is the frequency? 0.149. That's the event D. So you can write it, probability of event D is equals to, what is the frequency? Okay, frequency divided by total frequency. Okay, but here what they have given, they have given you relative frequencies. Relative frequency mean this one. Relative frequency mean frequency divided by total number of frequencies. So here they have directly given the probability. So this is gonna be 0.149 equals to 0.149. This is your answer, because they have given the relative frequencies. Relative frequencies, remember that relative frequencies exactly the probability value. Okay, they are same. What is the probability that the farm selected has between 100 and 499 inclusive, 100 and 499, which means we are talking about this. Okay, so those events are D, E, and F. D, E, and F. Okay, D, E, and F. So you can write probability of D, E, F. So in between these D, E, and F, what should we write? We should write O, right? Because we need to consider these values. So they have given relative frequencies, so you don't have to calculate like frequency divided by total number of frequency. No, simply you can add these three values. So 0.149 plus, oh sorry, I'll write it like this using our uh, additive rule. Okay, probability of D plus, do you remember this? Probability of E plus probability of F, which means probability of D, it is 0.149. We found it. Probability of E, D, E is, they have given 0.077, 0.077 plus probability of F 0, 1 or 6. Okay, once you add these values together, let me calculate this, plus 0.077 plus 0. So this is going to be 0.332. Okay, please calculate these values. Okay, I may be wrong sometime. So this is your probability. So what we use addition rule. We call this general addition rule, or we simply call this addition rule. Okay, we use our addition rule to calculate these probability. Why we use this addition rule? Because you can see here these events, any event, if you pick, let's say under 10 and under 10 and 49 acres, you can see these A and B events are what? Mutually exclusive. They are different events. Okay, they have no connection. Clear? That's why we use general relative rule. Okay. Just one more thing, complement rule. Complement rule means if you have an event E, you know what is the value of this event E. Then you can find the not T. Okay, not T. You know this one. Just think about, you know what is the probability of event E. You need to find the probability of not T. Okay, how we find it? Total probability is 1. Total probability is 1. So total probability minus probability of that particular event, PE, which means 1 minus PE equals to probability of not T. Okay, same thing they have mentioned here, the other side. Probability of E, you can find 1 minus probability of not T. Okay, they are equal. Okay, you can find probability of E if you know what is the probability of not T, or you can find probability of not T if you already know the probability of E. Okay. Okay, I'm not going to use this. I'm not going to do this example. This example clearly mention how you need to use this complement rule. Okay. Okay. There is another rule. Let's go to. Okay. Give me a second. Okay. Each time I have to share this screen. Yes, I saw this chat right now. So thank you. I'm sorry because I have to share my screen every time when I change the slides. Okay. Okay. Find the probability of this event E and F. So what are the probabilities of this? Find the probability of event E or F. You know the additive rule or special addition rule. So you can simply write probability of E or F equals probability of event E plus probability of event F. Why you can write? What's the reason? You can write like this, or you can use this you can write this addition rule like this, because of mutually exclusive. These events are mutually exclusive. So simply you can calculate these values. 0. Probability of E, they have given everything 0.3 plus this is 0.47. When you add these two, you can find this value is 0.77. Okay. Okay. Same thing you have to apply here if they are mutually exclusive. Okay. See, A and B are events, just events. They have given probability of A, probability of B, probability of A or B. Okay. They ask, are events A and B mutually exclusive? So how you check that? You can simply apply the addition rule or additive rule and check that value equals to this given P, A or B. If they are mutually exclusive, okay, I'll write there, if they are mutually exclusive, if they are mutually exclusive, then okay, then your probability of A or B should equals to probability of A plus probability of B. Using this formula, you can answer this question. Okay, they have given probability of A or B, it is 1/2. Once you calculate, see, you don't have to calculate, right? They have given everything. Probability of A 1/3, probability of B 1/4. You will see that these left hand side and right hand side are not equal, which means definitely know why A plus probability of A plus probability of B is not equal to probability of A or B. Okay, so they need to calculate to this value probability of A and B. Okay, so this value going to be this is the value 1/3 plus 1/4 is going to be 1/12. Okay, okay. This is very similar to the table example which we have done. The number of hours needed by sixth grade student to complete the research project was according with the following result. Okay, they have given hours and number of students, which mean frequencies belongs to each this given number of hours. Okay. 4 hours it has 16 number of students, something like that. So what they are student is selected random. Okay, event A is defined as follow. Event A is this: the event the student took between 5 and 9 hours inclusive. So student took between 5 and 9. Yes, the 5, 9 is here. Okay, so we need to consider this hours from 5 to 9. Okay, define as follows. What we need to find: determine the number of organs that comprise the event not A or not A. Determine the number of outcomes that comprise the event not A. Okay, so this is your event right here. This is belongs to event A. So not A mean what? Everything except event A, right? So what are those? This one and this one, right? So 16, just you have to find the numbers of outcomes. No probabilities, just outcomes. 16 plus 6. Okay, wait. 16 plus 6, it is 22. Clear? 16 plus 6, it is 22. Okay, uh, let's go to the next one. It is same as the previous one. You have to find the number of outcomes. Clear? First find the number of outcomes belongs to that particular event. First figure it out, what are these events, what is this event, or what are those events. Okay, then try to filter your answer. Okay, it is same as question number 4. We have a different one in question number 5. Find the indicated probability by using general addition rule. Okay, general addition rule. What's the general addition rule? Probability of A or B equals probability of A plus probability of B. Okay, this is the general additive rule. In city 59. Okay, just before I go to this question, I should say that you can convert any probability values to a percentage value by simply multiply them 100 by 100. Like any probability value multiply by 100, you can get the percentage. Okay, any percentage value divide by 100, you can get the probability value. They have that recursive relationship. Okay, just keep that in your mind. So in one city, 51.9% of adults are female, 10.5 of adults are left-handed, 5.19 are left-handed female. So if this event mean the person is female, event L mean person is left-handed. So you have to find probability of F or L. You can use general additive rule. probability of F plus probability of L. Probability of F, probability of L. Okay. General addition rule. Let me think. I didn't do that. Oh, sorry. Where was it? Oh, sorry. This is special addition rule. So general addition rule, I didn't do that. That's what I was thinking. There is something I missed. Sorry. Screen share again. Okay. Okay. General addition rule. Previous one is special addition rule. Special addition rule. It is probability of A or B if you have this kind of. If they are, what is the condition? Condition is mutually exclusive. Mutually exclusive. Probability of A plus probability of B. If they are mutually exclusive, you can simply use this special addition rule. But in general addition rule, they haven't mentioned anything like they are mutually exclusive. See, A and B, they are any two events. So that you can write to a general addition rule, probability of A plus probability of B minus probability of A and B. A and B. Why this happens? I can explain you by using a simple Venn diagram. Okay, this is A, this is B. Assume that they have a common space. Okay. Oh, sorry. Cannot change the colors. Okay. When you get the event A, which belongs to this area, right? Event A is this area. What is event B? Event B is this area. See, now you can see this area, which means this common area, okay, it colored twice. Once for A, the other time for B, okay. So since they colored twice, you have to remove one times. That's why this comes from minus probability of A and B, okay. That's a simple idea. Just keep that in your mind. When you use this picture, you can simply understand what is that. Okay, clear? So if I draw this, probability of A or B simply means it's like this, A and B. See this one, and this one. Okay, clear? So once they get twice, you have to remove it by using this part, probability of A and B. That's why they just use a minus negative probability of A and B. Okay. Okay, then I think I can go to the review clearly. Okay. Where was I? Okay, this is using general addition rule. Okay, general addition rule, PAOB is equal to PA plus PB minus PA and B. A and B. Okay, this is my and sign and B. Okay, so you need to find here FOL. So using this generalized rule, you can write probability of F plus probability of L minus probability of F and, okay, I'll write and by words. Okay, F and L. Sorry. Okay, let's try to find these values. Probability of F. What is F? F is the person is female. So how we find the probability values using this percentage? Simply divide them by 100. Okay, so 51.9%, which means in probabilities 0.519. Okay, clear? 9 adults are females. Okay, so female probability, which means event A, event F, probability of event F is equals to 0.1519. Clear? So what is L? Left-handed. See, everything they have given, you just need to pick the values and do the calculation. 10.5% calculate into probability values 0.105. 0.105. Okay, and we need to find probability of F and L, common outcomes, probability of common outcomes for these two events. I think this is the value, right? 5.19% are left-handed females. Yes, what is this F and L mean? F is female, left-handed. L is left-handed. So and mean F and L mean female left-handed. So they have given 5.19 are left-handed. So convert it to probability, which means divide by 100, 0.0519, right? So once you calculate this value, you will get 0.126 plus 1 7 0.579422. Okay, this value. Okay, so that's how we use the general relative rule. This is also general relative rule questions. They have given PA, PAOB, PA and B. You have to find the PB. So you have to just swap the terms. Okay, then you can figure it out. Okay, I'll do this example. What is the general relative rule? Probability of A OB equals to, why we use general relative rule? Because they haven't mentioned these events are mutually exclusive. If they are mutually exclusive, we can use special relative rule, but here we don't have that. So probability of A plus probability of B minus probability of A and B. Clear? So what you need to find? This guy. Clear? Isolate this guy and find the, because you know this value, this value, this value they have given. Just plug the values and find the probability of B. It should be 43 out of 132. Okay, you can use calculators, no problem. You have to use them. What is this question? Okay, table. It's about the number of siblings and their probabilities. No, number of siblings and their frequencies. You have to find the probabilities with respect to number of siblings. Okay, they have given this frequency table. You have to convert it into a probability value table. Okay, so I'll tell you a quick way to do this, quick way to solve this problem. You don't need to calculate each and every uh, probabilities for number of siblings. Question like this, first look at the table and try to eliminate answers that are not directly related to this problem. Okay, so okay, check this one. Number of siblings 0 1 2 3 4 5 6 7. Related frequencies are different, right? For number of siblings 0 195, number of siblings 1, frequency is 255. They are different. So since they are different, those probability values cannot be equal like this. Clear? So you can simply remove this first answer. Okay, and also since probability, how we calculate the probability? probability is equals to uh, relative frequency, sorry, a frequency divided by total number of outcomes, right? Total number of outcomes. Okay. So if this frequency value increases, then probability also increases, right? So you can see that I don't know what is the total outcome here. You have to add these 195, 255, 132, those values, and get the total number of outcomes. But you can see each frequency is 195, 255. Between those two, 255, which means number of siblings 1, should it should has the highest probability because its frequencies is greater than all other values. Okay, so now you can find number of siblings 1. It sorry, number of siblings 1 should has the highest probability. So let me check that. Yes, answer B and C, yes, it satisfies. So what's the problem with answer D? There is no number of siblings 0 in this answer. It is start from 1. So simply remove this answer D. Okay. So sorry, using B and C, you have to pick the correct answer. Still, we haven't do any calculation. We haven't done any calculation. Okay, we haven't done any calculation. Okay, now you can do calculations. Just pick one particular value set and do the calculation. I don't know what is the let me check what is the total number of outcomes. It should be 195, 255, 132, 57 plus 24 plus 9 plus 5 plus 1. Total number of outcomes is 678 if I'm correct. Okay, wow. It doesn't matter, just add the frequency values, get the sum of these frequency values, divide by, okay, that's the total number of outcomes. So which frequency, which probability we are going to find? Let me use 1, number of siblings 1. Okay, for number of siblings 1, number of siblings, okay, I'm going to find the probability which belongs to number of siblings 1. So what is the frequency? 255. Divide by total number of outcomes, 678. So 278 divided by 678. I think total number of outcomes goes wrong. 24 plus. Let me calculate that again. Yes. Okay. If we calculate number of siblings 0, for an example, okay, number of siblings 0, this is going to be 195. Then answer is 0.2876, which mean 0. You can simply write 0.288. You can round it up, okay, which means this value. Okay, so in the first one, answer is wrong. So answer going to be this one. Clear? It doesn't matter which one you pick. If you pick this part, it doesn't matter. Anyhow, you need to calculate just one probability value. Okay, then check that value is correct or not with your table. Okay. Sorry. Okay. Sorry for that. Okay, let's move to next question. Oh, okay. Up to question number 7, it is chapter 5. Okay. Uh, from question number 8 onwards, it goes to chapter 6. So chapter 6, it is little bit different from the other chapters, because from chapter 6 we start to talk about a giant theory, giant theoretical part called normal distribution. Okay, so okay, before I go to this question, I'll explain normal distribution a little bit, because you need that idea to do this exam. Okay. Oh, sorry. Let me done this. Okay, chapter 6. From the current, then I can share my screen. Okay, this is chapter 6, normal distribution. Why this normal distribution is important? Because we have to use it almost everywhere. Okay, you know what's the distribution? Distribution is the shape of that particular variable, how it deals with when it's increasing. So if you consider a density curve, okay, density curve is always on or above the horizontal axis. If you draw a density curve, okay, horizontal axis is this one. So density curve always on or above. This is just a rough shape of the density curve. Okay, so it's always on top of this horizontal axis. Clear? This is the horizontal axis. Total area under this curve, I'll use these lines. So total area under this curve equals to 1. Okay, so this is the horizontal axis. So your density curve always above the horizontal axis. So total area belongs to total area which covers by this curve, or total area belongs to this curve, is always 1. Okay, variable and their density curves. For different variables, they may have different density curve shapes, so density curves. Okay, if you consider this kind of density curves, if you get a density curve like this first one, okay, and I get a value, let's say a fixed value C, we can tell the percentage, which means the areas, to the left or to the right to this value, regarding with respect to this value. Okay, so consider this value is C, so I'm going to tell you the area with respect to this C. So I can say I have colored this left hand side area, whatever from left hand side to this C. C is a value. Okay, percentage of all possible observations of the variable that lie to the left of C equals this area. Okay, so we call that area to the left of that particular value. Here value is C. So area to the left of C, which means values from your left hand to that uh, point C. Area to the right of C mean, or here you can use D. Area to the right of D mean whatever start from D to your right hand side. Start from D and your right hand side. Clear? Area to the right of D, which means everything above the D, or everything right hand side the D. Okay, between, area between A and B mean, here you have A and B. Area between A and B mean simple, like that's easy, area in between these two. Okay, so try to remember these two words. Okay, check this one. Area under the density curve that lies between 3 and 4 is this much, 0.387. Okay, area. What percentage of all possible observations of the variable lie between 3 and 4? So wish me this one. This is your density curve. Normally we draw this density curve like a bell shape. Okay, because in your syllabus you have to deal with this bell shape density curves only. Okay, you don't have to worry about the other shapes. There are so many shapes, but you have to worry about this bell shape curve. Okay, so always when I draw a density curve, I'll draw them like a bell shape. Okay, uh 3 is somewhere here, 4 is somewhere here. Okay, so they have given that in between 3 and 4 this area is how much? 0.387. Okay, what percentage of all possible observations of the variable between 3 and 4? So 3 and 4 probability they have given, or area they have given, remember that area and probability they are same thing. Okay, because we are dealing with this area, same thing as the probabilities. Okay, so area 0.83, which means probability is 0.83. They ask the percentage. How you can convert this probability to percentage? Multiply by 100. So 0.83 multiplied by 100, it is 38.7%. Clear? Okay, area under the density curve to the right of 2. Okay, okay, to the right. So my 2 is here, to the right of 2, which means whatever start from 2 to your right hand side, which means this area. Okay, actually this density curves, especially normal density curve, they are starting from negative infinity and goes up to positive infinity, like this. Here you can find the positive infinity, here it's negative infinity. Okay, so don't worry about these end points, just draw your uh, density curve, something like this. Okay, okay, curve to the right is 0.76. What percentage of all possible observations of the variable exceed 2? To the right 2 and exceed 2, they are same, right? So they have given the probability values, they are or area 0.762. You have to simply multiply them by 100 to get the percentage. So percentage is 67.2. Okay, okay. Normal distributed variable, a variable, if a variable is normally distributed, we call that it's a normal distributed variable. Okay, normal distributed variable has a shape of a normal curve, this bell shape. Okay, frequency distribution. Okay, this is just an example. You have to You can go through this. They have given frequencies and their relative frequencies as well. Okay, and they have shown here histogram, and connect the midpoint of this histogram, man. You can see here it is a bell-shaped curve, right? So this shape called a normal curve. Okay, the distribution of that height, distribution of this height, we have a normal curve. Okay. So same same idea here. Percentage we calculate under the curve, area under this curve. Okay. Uh, when we are dealing with a normal distribution or normal distributed variable, there are in normal distribution there are two parameters you need to know: mean and standard deviation. Mean and standard deviation. You know what is mean and standard deviation because you have done those in previous chapters. So mean we mention by Greek letter mu, and standard deviation we denote by simple sigma. Okay, so these two parameters are really important when you are dealing with normal distribution. Okay, two normal distribution variables have the same mean and same standard deviation. Two normal distributions. Okay, if two normal distributions they have same mean and same standard deviation, then they must have the same distribution, which means they are equal. Okay, normal distribution is symmetric about zero center. Normal distribution is symmetric above mean mu. Okay, if mean mu is 0, then it is symmetric about 0. If mean mu is 1, then it is symmetric about 1. Okay, so normal distribution symmetric about, it is center, we call mean. Center is the mean mu. Okay, population is normal distributed, and the only one variable under consideration, we say that population is normally normal distributed. Okay, if that variable, if our variable is uh, normal distributed, if our population is normal distributed, okay, if a variable of population is normal distributed, the variable under consideration, we say that the population is normal distributed. Okay, variable of that population is normal distributed, simply we call that the population is normal distributed. Okay, the variable distribution shape roughly normal curve. Yes, if a variable distribution shape is roughly a normal curve, then we say that variable is approximately normal distributed. Approximately, it is not perfect normal distributed, we call it approximately normal distributed. Okay, since we discussed normal distribution, there is another one we call standard normal distribution. The difference between normal distribution and standard normal distribution is mean is 0, which means mu is 0 and sigma is 1. In standard normal distribution, mean mu is 0, standard deviation sigma is equals to 1. So that we call standard normal distribution. So it's symmetric about 0 and standard deviation is 1. Okay, that's the difference between normal curve and standard normal curve. Okay, so if we have a normal curve, we can, okay, this is your normal curve. You have your mean mu here, you have sigma. You can convert your normal distribution, your normally distributed variable, into a standard normal distribution like this, using this formula: C equal x minus mu, x mean each possible outcomes, minus mu divided by sigma, so that everything it looks like this: mu equals 0 and sigma equals 1. Okay, you can convert like this. So most of the time we use this. If we have I'll explain you later, we have C table and those stuff. C table is based on standard normal distribution. So if we have a normal distribution, we have to convert that values into standard normal distribution and then do our calculation. So we have to convert. Okay, so keep this in your mind. This is standard normal distribution. That's how the distribution shape of that distribution deviate from this mu and sigma. Okay, here mu -2, which means center -2, sigma 1. Here mean mu is 3, center is 3, sigma is 1/2. Okay, mu we call location parameter because when we change the mu, it shift your distribution. It shift. So mu shift your distribution. Sigma we call shape parameter because it change your shape. See, if sigma is equals to 1, it's like perfect bell shape. If sigma is 1/2, it's like shrink, right? It's like squish your distribution. So sigma is a shape parameter. It's shape. It tells about the, it tells you the shape about your distribution. Okay, so once sigma increases, then the shape of your distribution, like it's like coming down, peak coming down. Okay, peak is coming down, something like that. It doesn't matter the shape of your distribution. You can simply convert to a distribution to a standard normal distribution like this using the previous equation. Okay, using your mean and sigma. Okay, now let me check our review again. Okay, we were, yes, here. Okay, area under the table, area under the density curve. Okay, this is your density curve, area under the density curve that lies between 27 and 48. Okay, so roughly you can mention your values here or here, it doesn't matter. Okay, between, lies between these two, which means this area is 0.525. Area is 0.525. What percentage of all possible observation of the variable are either less than 27, or greater than 48, greater than 48? They have given this much area in between 27 and 48, right? So you need to find the area less than 27, greater than 48, and convert them to percentage, right? So it is easy, right? How do we find the area not belongs to this 27 and 48? You know what's the total probability under this curve? It is 1. So 1 minus this 0.525 is equals to 0.475. What is this 0.475? Area does not belongs to this colored area, right? So that's actually what we need, right? But we need percentage. So simply what you have to do, multiply this by 100. So it's going to be 47.5%. Clear? So number 9 is same as the number 8. Let me check number 10. Okay, number 10 is a little bit different. Standardizing the normal distribution. Okay, standardizing normal distribution. Dave tries to work at the same time. Normal distribution. Okay, if they have mentioned your situation is normal distributed, then you don't have to worry about that. Simply apply your techniques. Okay, with mean, they have given the mean 55, standard deviation is 8. Okay, percentage of time that his commute time lies between 63 and 71 minutes is equal to the area under the standard normal curve. Yes, standard normal curve. Mean mu equals 0, right? So they have his commute time is normal distributed. It is normal distributed. Mu has a value 55. Mu is the mean. Sigma is the standard deviation. It is 8. So what you have to do? You have to convert this into a standard normal distribution or standard normal curve. This normal curve to standard normal curve by using what? C equal x minus mu divided by sigma. What is x? X means each uh, each outcome. Okay, so here you have okay, I'll show that 63 time between 63. So your mu is here, so 63 somewhere here and 71 somewhere here. Okay, so this is 63, this is 71. So you have to convert these values using this equation. Okay, so 63, now my x is 63 minus mu is 55 divided by sigma is 8. So it's going to be this is 8 divided by 8, it is 1. Okay, so your new value is 1. Your new value which belongs to 63 is 1. Clear? Then the other value 71. Now your x is 71. 71 minus 55 divided by 8. This is going to be 16 divided by 8, it is 2. So now your new value for 71 is 2. Clear? So let me draw this using another color. This 63, okay, 63 convert into 1. 71 goes to 2. Okay, that's how this conversion works. Clear? So they ask this, no problem. The values are 1 and 2. So under the area under the standard normal curve between 1 and 2. So we have converted those values. Clear? So that's how we converted values. Number 11 same as number 10. I think 12 is same as the previous question. Don't worry about the negative positive. Okay, just plug the value x and do these calculation and get the standard normal value. Okay, that's how we deal with. So standard normal value can be negative, positive, doesn't matter. Don't worry about that. If they have mentioned round your answer, please round your answer to the mentioned decimal. Here they have mentioned round to 2 decimals, so you have to keep 2 decimals. You have to get the answer for 3 decimals and round up. Actually, normally we round up to 2 decimals. Actually, this round up or round down based on the value of this third decimal. Okay, if that third decimal value less than 5, then you have to round up, round down. If that third decimal point value greater than 5, then round it up to the two decimals. Okay, that's how we uh, round up and round down. Okay. uh, okay, I think this is actually I need to explain you today, because this chapter 6 is a really big chapter. Okay, so after this point we have to use C table. So I'll explain you how to use C table. Actually already I have sent you an document how to use C table, but anyway I'll explain you how to use C table and deal with these calculations. So I'm thinking that it's better if I stop from here and do the rest of your review uh, on Thursday. Okay, so because chapter 7 is we have only I think few questions, so don't worry about that. But chapter 6, I think it is the dominant chapter in this exam. There are so many questions in chapter 6, so I'll more focus on chapter 6. As I mentioned, you will be having 24 questions. Okay, 24 questions, including 4 bonus questions. Okay, so you have 20 questions plus 4 bonus questions. All are multiple choice questions, same as you in exam 1. So if you have any questions, you can simply email me anytime, it doesn't matter, or you can ask right now, or you can ask next day, it doesn't matter. I'll open the exam on this Friday to 12 a.m. Okay, so it will be due next day, which means Saturday 11:59 Central Time, 11:59 p.m. Central Time, which means exam opens like about 2 days. Okay, if you have any questions or if you have any complications regarding to your situation, your health condition, so please let me know. Okay, I'll do my best to help you. Okay, so thank you very much. If you have any questions, you can ask me right now or email me. I'll try to get back to you as soon as possible.